So, experimental chemistry will carry on with purification analysis to purify things. The most important thing for a chemist, no doubt, is to prepare, to make things, but to present them, to market them in maximum purified form. So at this basic level, you'll definitely learn how to purify things, especially how to purify mixtures. Because mixture is a substance which is impure. Compound is pure, element is pure, but mixture is an impure thing. It has things physically mixed, not chemically attached. So a mixture is a combination of two or more things physically attached, and each component has maintained its properties. Like air we are standing in is a mixture. Okay, it's a homogeneous mixture, no doubt. That composition is same almost everywhere, throughout. Okay, so you can't differentiate this part is nitrogen, this part is oxygen. It is totally dissolved into each other. Nitrogen, larger part, 80%, is acting as solvent, and oxygen and other gases are acting as solutes. But uniform mixture, we call homogeneous mixture. But this can also be separated, because nitrogen has maintained its own property. Oxygen has its own property. So based on their physical properties, like their boiling points, they can be separated out. Sand in water. Sand has its own property, water. Salt in water, separated because the mixture has components that maintain their properties. So based on their physical properties, which they actually keep intact in the mixture form. Remember, in compound form, they lost their properties. Hydrogen, flammable thing, oxygen helps in combustion. But when they react, it's water. You cannot find any trace of hydrogen or oxygen in water. But you can electro-decompose it. That is also a chemical reaction, electro-decomposition. And you'll get hydrogen at one electrode and oxygen. But if it is a mixture, physical attachment, things are physical. We apply physical methods. And the most common physical methods are filtration, crystallization, we have evaporation, sublimation, we have distillations, fractional distillation, simple distillation, chromatography, and using separating funnels. So to start with, keeping things simple, filtration we apply when we know that solute is insoluble. Solutes are insoluble. There are few things which are not dissolved in. They are making a sort of suspension. The particles are suspended. So when we pass them through a filtrating medium, solvent will pass and solute will stay behind. Because solute particles are big enough, they cannot pass through, they cannot penetrate. So that's one way, easy way of separation. Large scale filtrations are done all around the world, especially for purifying what? Water. Large reservoirs are there in the world, like river water, like the water obtained from many places, okay, lakes, many places, like it can be the water out of the rainfall being collected somewhere. I mean, a reservoir you have, it has plenty of impurities, but they are suspended. So pass them through series of filters, as all around the world the city water filtration plants are doing. Series of filters are almost just like the being filtered by the nature. And there are layers of sand, there are layers of pebbles, there is a sort of wire mesh placed in between, okay, gravel, pebbles, sand, natural filtration stuff, and then the wire mesh. As it passes through, suspended impurities are trapped, suspended, insoluble, and then it passes through, we know, through the wire mesh, suspended impurities are removed, and then we know that now it can have bacteria or other germs, and chlorination is done. Chlorine kills the germs, okay, and then the water may have a chlorine smell, so there may be a little layer of charcoal placed. The charcoal is deodorized. It will take away any odor in it, and then to make it healthy, we add what? Some fluoride salts. They help to prevent tooth decay, and water is supplied around. So look at series of filters, they remove the suspended impurities. Or simple filtration, as you do in the lab, you can show, you have a filtrating funnel. Look at, this is the filtrating funnel. And the filtrating funnel basically has what? Has a filter paper. And the filter paper, when you place something insoluble here, the filter paper never let the insoluble thing, but soluble things are passing through it. And this is basically the filtrate. This is called filtrate. And the thing that is left behind is called as residue. So insoluble stuff is collected as residue and soluble passes through. Anything in a cloth can be a filtrating medium. Any filtrating medium, whatever you have in the hand, that will remove the suspended impurities. Okay, so filtration. Then if the solute is soluble, like salt is soluble, sugar is soluble, then you can apply evaporation. Evaporation, the word means evaporate it off. Cost of the solvent, remove the solvent and you left behind what? Solute. Like seawater can be placed in the sun even, and the sun actually steals the water away. Heat it up, water vaporizes as it normally does. In sunlight definitely it does more, and the left behind will be the salt. Okay, salt is collected. Evaporation is done anywhere in the lab. We remain careful in evaporation that solute must withstand strong heating. It should not get decomposed. Like if it is sugar, you cannot actually evaporate because it will decompose, turn to caramel. Okay, you need to be very gentle, you need to be very careful. Okay, in case of such solutes which can decompose or unstable, you have to use what? Crystallization. Okay, when we say crystallization, it means you are making crystals. Crystallization. What crystal is? A thing which has a definite geometrical shape. But when we do crystallization, crystalline things get out in the pure form. They are purified, devoid of impurities. Because for crystallization, you take a substance, impure, plenty of impurities, you dissolve that into somehow a beaker, and then you stir around, only the soluble part dissolves, okay, your substance dissolves, impurity stays behind, okay, and then we do filtration. When we do filtration, impurities are as residue and the filtrate is there. The filtrate has solvent largely and the solute that you want, and then you shift it to the evaporating dish. And in the evaporating dish, you heat, gently heat. When you feel half the volume is evaporated, let it stop heating, let it cool. Slow evaporation will produce big size crystals, because when a substance turns into crystals, it adds in what? This water of crystallization. Like this is copper sulfate anhydrous. 5 water molecules, when they are added, it turns to copper sulfate dot 5 water molecules, mean weakly bonded. Okay, this is crystalline part, this is anhydrous part, this is hydrous part, this is anhydrous part. It's hydrated. This one was without water, but we turn it into crystals. Look at, every salt has its own crystallization point. Iron sulfate has 7 water molecules it need to turn into crystals. That is the reason it's water of crystallization. If you heat strongly, it may also evaporate. Plenty of other ways of crystallizations in nature also exist, like the magma cools crystals, rocks turn into granite crystals. And when we do in the lab, sometime you want to enhance crystallization process, then your saturated solution, which you have heated gently, then you want to leave it there and place a seed crystal of the substance already present. All the crystals will get stuck to it. We call it a seeding method. Okay, seeding. Saturated solution, you add a crystal with a thread which is the crystal of the substance you want to purify, separate out. The other crystals will get stuck to it. Okay, that's seeding method. But the important thing is crystallization is a purification technique. Crystalline sugar, like industry produce crystalline refined sugar. Okay, industrial application, refining of sugar is crystallization. Industrial application, refining of rock salt is crystallization. Rock salt, you see, has plenty of other impurities, other salts may be useful as well, but you want only the NaCl. For that case, you just simply crush it, break it down, and then when you dissolve, impurity stays behind, and the solute is salt, it dissolves. And then you filter off the impurities and the filtrate. The soluble sodium chloride is in the filtrate. You heat it, vaporize, and left behind is the salt. So crystallization.